law of sines versus law of cosines versus right triangle trigonometry. Which one should we pick? So let's first take a look at when should you use the right triangle trigonometry. All right, to review, right triangle trig uses SOHCAHTOA to help us remember the trigonometric ratios. So when should we use this? We should use this if we have a right angle and two more pieces of information. So if we want to solve the triangle using right triangle trigonometry, we can draw the picture. So angle A is 90 degrees. Angle B is 48 degrees. And then we don't know angle C, and we know side B is 12. So if it said to solve the triangle, we need to find all the missing sides and angles. So we are missing side A, side C, and then the measure of angle C. So the easiest one to find right away is the angle. So the angle, just subtract from 180. So 90 plus 48, subtract from 180, 42. Okay, next to find side A, that would be this one, and then this would be side C. Starting at your 48 degrees, think we have opposite and hypotenuse. So that's going to be sine of 48 equal 12 over A. So then if we move A to the other side and divide by sine 48, we end up getting A equals 12 divided by the sine of 48, which equals 16.1 to the nearest tenth. Might want to keep it, let's actually keep it 1.5 for now, and then when we round it at the end, we'll go to the nearest tenth. So up here we can put 16.1. I guess we don't need to use it. Okay, here we go, angle C, or side C. So now I'm going to use opposite and adjacent, which would be OA, tangent. So I go tangent 48 equals TOA, opposite over adjacent. So if we multiply both sides by C and then divide by tangent 48, we get C equals 12 divided by the tangent of 48. And C equals 9.9. 9.90. Oh, to the nearest 10, 9.9. All right, so that was when we use right triangle trigonometry. For the next one, law of sines, we'll use law of sines if you are given a side and the angle across from it. You need one pair at least in order to use the law of sines. So let's review the formula. So we have sine A over side A, sine B over side B, and sine C over side C. All right, so then we can set this up. Sine of 34 over the side across from it, 12, equals sine of C over 14. So you can cross multiply and divide. All right, so we get 0.6524, but that still equals the sine of C. So then we take the inverse sine. Remember, on your calculator, you can use that answer button, and that will tell me the measure of angle C, which we got 40.72. Even though it says nearest tenth, again, let's just leave it to hundredth for now, and then we'll round it then. Might even use one more digit. There we go. Okay, now, because this is the side-side angle case, we need to check if there's two triangles. So we got one angle to be 40.722. To check if there's two triangles, remember, we can take 180 minus the angle we got. To find our new angle. So it was 139.278. And then if I see, does that work? Does 139.278 plus the original angle, which was 34, is that less than 180? Barely, but yes. 173. Okay, so that means this one has two triangles. So I don't think there's one like that on your assignment, but if you had two triangles, then we would have to continue and solve both triangles out. So like over here, we have triangle ABC, and then here is our second triangle. So in both of them, A is still 34. B, we don't know, let's see. Side A was 12. Side C was 14. And then in one case, our angle was 40.722, or we can just go 40.7 now. And then in case 2, our angle A was, or C was 139.278. Okay, so then to find that last angle, we could subtract from 180. And then finally, we could use the law of sines to find the sides across from it. All right, we're going to go ahead and jump to the last problem. This one is using law of cosines. So we can use this on any triangle. It's usually if you know all three sides or the included angle, like side angle side. So for the example we're given here, it says, solve the triangle using the law of cosines and then the law of sines. Let's fill in our law of cosines up there. A squared equals B squared plus C squared minus 2BC cosine A. Okay, so we've got the triangle ABC. A, B, C. We know side A is 5. Oops, side A is 5. Side B is 6. Side C is 7. So let's go ahead and find angle C first. You could actually find any of them first, but let's go ahead and do angle C. So we're going to go 7 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 cosine of C. All right, so then we can square the 7 squared, square the 5 squared and 6 squared to get 61, and then take negative 2 times 5 times 6. That's supposed to be a 6, which is negative 60 cosine C. So then we subtract 61 to the other side. So we're left with negative 12 equals negative 60 cosine C. We need to divide by negative 60. Then finally, we can take the inverse cosine of both sides. So we get the measure of angle C equals 78.5 degrees. Now we need to use the law of cosine or law of sines to find one of the other angles. So if we wanted to find, for example, angle B, we can use angle B and 6 with the pair we just figured out. All right, I am going to actually leave this not quite rounded as much yet. So it was 78.463, just so I get a more precise answer. If you don't, that's fine. You don't have to. All right, so we're going to go sine of 78.463 over 7 equals sine of b over 6. So we get 0.8398 equals sine of b. Now do the inverse sine. And we get 57.121. So measure of angle B is equal to 57.122, we'll say. Okay, so we can go 57.1 on here. So then if I add them all together and subtract from 180, we can figure out angle A. So to summarize, what was angle A? What was the measure of angle B? What was the measure of angle C? All right, we should have gotten the measure of angle A to be 44.4 degrees, B to be 57.1 degrees, and then C 78.5 degrees. All right, so go ahead and finish this. So this page and the next page, 15 and 16 is your assignment. All right, let me know if you have any questions.